Alright, this is U Texas, Newton Extra, questions 8 and 9. Question 8, here's what the little drawing is, and you're trying to find the tension T, which is right here, for this left-hand cable. So pretty much what you have to realize, I'm going to go ahead and erase this, you should have this on your paper already, is that F net equals 0, and your X direction is left and right, and your Y direction is up and down. Now, it takes me long to use. Okay, so you're pretty much going to have these two triangles. We pretty much got this triangle nailed down. We got a lot of information for this one. So we're going to use cosine for X, and we're going to use sine for Y when we're doing our forces. So defined this X force, we're going to plug it in for 620 cosine 37 degrees. Now that should give you 495 dot dot dot. If not, your calculator needs to be in degree mode. That might be your issue. Okay, now another thing you have to realize is that this is the same for both sides because they have to equal out. It's not moving left and right to hold this weight. It's moving up and down. And that's really sloppy, but these two are going to be the same. Okay, now that we have your X force, because they're both the same, so you have X forces for both sides. Should I just click that? Alright. And then, okay, so now we have to find the Y force. So we have the X. Now we need to find the Y. So we have your down weight is going to be 6, or on my sheet it's 602, whatever it is on yours. You're going to subtract 602, which is the weight. If you have a different number, plug that in, minus the force you have for the right tension, sine 37. That is going to give you your Y force. Actually, hold on a second. That's going to give you your Y force for the left side. Okay, so that should give you, when you plug this in, 228 dot dot dot, whatever else the decimal places are. Okay, so let's wipe this off. So far we have, for your left side, because that's what we're solving for, you have your Y, which is 602 minus 620. Right, you get the picture. You got your Y and you got your X. Now I suggest from this point you store it in your calculator. So you should store your, what was the answers? It was 495, so store that for A, and then for that was your X equals, so, and then now for your Y, let's store your 228 as B on your calculator. Okay, so now you're gonna have to plug this in because we're trying to find the tension here. So we're gonna use Pythagorean theorem. So now you're gonna have your A squared plus B squared equals C squared. So you're gonna have your plug it in. It makes it really easy for your if you use your calculator, equals, you're gonna have C squared when you're done. So you're gonna have to square root whatever answer you get, which I got like 2,97561 something. So once you square root that, you should get your final answer should be 545.4916. So that should be your final T tension on this picture. That's your T for this. Because if you look at an imaginary triangle, that is your hypotenuse. Okay, now for moving on to question number 9. Now that we have A and B and C, we need to find the angle theta, which the left hand makes respect to the wall. Okay, so that means we need this little guy. So wiping that off, we need this. Okay, so your A is there and your B is here, I believe. Actually false. Your A is down here and your B is up here. So now all we're going to do is just do inverse tangent, which is opposite over adjacent. And then to make this super easy for you, now that you have it all stored in your calculator, you're going to plug in tangent inverse 1 A over B, which is, if you didn't store it, it's going to be 602 minus 620 sine 37. Pretend that's 37. And that's going to be over 620 cosine 37. And once you plug that in, either one of these are good, you will get 65.1922 degrees. Alright, well that's question 8 and 9 for UTexas.